A pole shift could change our world forever. What the upcoming geomagnetic reversal will do to the Earth is shocking, and we have virtually no way to effectively protect ourselves. The reversal is sure to come, but no one knows when. Many questions remain about this millennium event. How will we know that the poles have changed? Can we, as humans, feel the effects? And can we, as individuals, take precautions? The pole shift is long overdue. The last reversal took place between 772,000 and 774,000 years ago. The geomagnetic reversal of the Earth's magnetic field is not a possibility we have to expect in the next million or thousand years. The jump is imminent or has already begun without us realizing it. A pole shift is when the Earth's north and south poles swap places. A compass that previously pointed north would suddenly point south. It's like when the Earth decides to turn its magnets around. This has happened many thousands of times in history, but never before have we experienced such an event in our technologized age. The pole shift is likely to take several decades. Scientists can see this in the constant shifts of the magnetic north and south poles. The actual jump is very likely to take place after a certain degree of deviation from the old positions, and then it could happen very quickly. However, it is also possible that the North and South poles change their positions over a period of dozens or hundreds of years. We simply don't know exactly. The question naturally arises as to how scientists would even know that this event is happening. The answer to this exciting question also shows how pole changes affect nature. Clues are provided by rocks and the seabed. When magma emerges from a volcano and hardens into solid rock, it stores information about the Earth's magnetic field at that time. When examining such rocks, scientists have seen that the direction of the magnetic field has changed over time. Magma is also active on the seabed in many places. On the seabed, hot material emerges from the Earth's interior constantly, reforming the Earth's surface. At the moment of solidification, magma is also magnetized and forms stripes on the seabed that alternately point in different directions. These stripes are like a tape measure of the Earth's history and show that the poles have reversed several times in the past. What if the Earth's magnetic field collapses? One big unknown is actually the question of how the Earth's magnetic field will behave during this time. The protection of our planet from solar radiation depends on the Earth's magnetic field, among other things. A weakened geomagnetic field could promote devastating solar storms that could paralyze our entire electricity and communications network. Researchers suspect that the Earth's magnetic field will weaken considerably shortly before the actual jump, or even collapse completely for a short time when the polarity reverses. The consequences of this process could also be devastating for nature. Birds and other animals would lose their orientation. Marine mammals orient themselves to the Earth's magnetic field and could be stranded by the hundreds or thousands. And in the worst case, die. Even bees use the Earth's magnetic field. Imagine masses of unconscious and disoriented bees. A loss of work by these animals could lead to considerable crop failures for us humans in terms of fruit and other foods. Researchers warn the Earth's magnetic field has already decreased in the last 3,000 years. The European Center for Research and Teaching of Environmental Geosciences in Aix-en-Provence has been studying the effects of the pole shift and possible consequences for decades. If the field continues to fall so rapidly, we will soon enter a critical phase. Researchers measure the Earth's magnetic field with specialized instruments, such as magnetometers, which record the strength and direction of the field. Satellite missions, such as the European Space Agency's SWARM mission, supplement this data and detailed observations from space. There are several magnetic observatories around the world that continuously monitor the field and record any long and short-term changes. Our magnetic field is very lucky. Did you know that our planet's magnetic field is mainly generated by the flow of liquid iron in the core? It has always been a special feature of our planet, and we are lucky to have this field because, without it, we humans and all the wonderful wealth of life forms here would probably not exist. Our neighbor Mars only has a very weak magnetic field because the interior of the planet is structured differently. Due to the lack of protection, Mars has always been more exposed to solar radiation than Earth, and over millions of years, it has almost completely lost its atmosphere and water. If there was once life on Mars, it fell victim to desolation and desiccation. Venus has no magnetic field at all, which may be why it has become too hot and inhospitable a planet, while our Earth is thriving and prospering. So, without a magnetic field, we wouldn't exist. And of course, it's scary to know that it could collapse in the next few years, even if only temporarily. Researchers currently suspect 100 pole jumps in the last 20 million years, with studies showing that some reversals have taken up to 1,000 years. Does the already visible decline in the Earth's magnetic field mark the beginning of such an era? Or has the jump come suddenly once again? Researchers have to pass. They don't know. We can only observe and hope that the effects we feel will be limited. The fact is that the Earth has survived all the jumps in the past. However, we do not know exactly what effects the jumps had at the time, whether there were climate changes, and whether and how many species became extinct. For a polarity reversal to occur, the magnetic field must be weakened by around 90% to a threshold value. If this process takes thousands of years, the Earth would potentially be less protected for a very long time. During this time, more high-energy particles from the Sun and other parts of the universe would hit us. These cosmic rays collide with nitrogen and oxygen atoms in our atmosphere. This can create completely new variants of elements known as cosmogenic isotopes. Traces of carbon-14 and beryllium-10 in rock deposits are directly linked by researchers to past polarity reversals. Since the last complete jump more than 700,000 years ago, the Earth's magnetic field has almost reversed 15 times, but not completely. Scientists call such wobbles excursions. The last of these excursions took place 40,000 years ago. It is possible that we are now seeing the signs of another excursion, and the strength of the field is decreasing considerably, but not collapsing. What does the South Atlantic anomaly reveal? In the Atlantic Ocean between South America and Africa, there is a wide area of the Earth's magnetic field that is about 3 times weaker than the field strength at the poles. This South Atlantic anomaly, or SAA for short, is caused by a peculiarity in the Earth's crust, in the Earth's core where the magnetic field is generated. There are changes in the flow of molten iron in the region corresponding to the SAA. Above the SAA, scientists observe that satellites are constantly experiencing electronic failures. Scientists first noticed the SAA in the 1950s, and since then, the Earth's magnetic field there has decreased by a further 6%. The South Atlantic anomaly is not only getting stronger but is also moving conspicuously to the west. Scientists are unable to explain the phenomenon precisely and find it difficult to predict how it will change. It's also still unclear to what extent this anomaly is related to or influenced by a possible imminent pole shift. In any case, the satellite disturbances that are already being observed are worrying. Imagine all satellites suddenly failing. There would be no more internet, GPS, or television, and most communication systems would also suddenly fail. This catastrophe could have devastating consequences. Rapid movement of the magnetic North Pole, researchers are faced with a mystery. Another phenomenon observed in the Arctic is causing a stir. Since records began in 1831, the magnetic North Pole has moved several times in a remarkable way. Originally located in Canada, it has now shifted around 1,100 kilometers towards Siberia. The magnetic North Pole is a constantly moving point that is determined by the activity of the Earth's magnetic field. The geographic North Pole, on the other hand, is a fixed point that marks the northernmost point of the Earth's axis. This motion of the North Pole is striking, not only because of the great distances involved but also because of the increasing speed of movement. While the pole initially moved at a speed of around 16 kilometers per year, this rate has now increased to around 55 kilometers per year. These changes provide evidence of dynamic and complex processes taking place deep inside the Earth. They are probably signs of fluctuations and changes in the Earth's magnetic field caused by movements in the Earth's outer core. These movements are probably part of the Earth's natural cycles and are completely harmless. However, they may also be harbingers of larger events, such as geomagnetic reversal. We currently know very little about what is actually happening inside our planet, and our ability to study this is limited. Researchers mainly use seismic waves to listen deep into the Earth. Earthquake waves traveling through the planet are reflected by different layers and elements in various specific ways, and this reveals many exciting details to scientists about what is happening inside the Earth. We have been collecting this data for many decades and are now able to understand the physical conditions in the Earth's core fairly accurately, thanks to state-of-the-art computer simulations. But we know too little about its cycles and changes. These technologies have only been available to us for around 100 years. The day after the pole shift, let's assume you get up the morning after the pole shift. At first, you probably wouldn't notice anything. You might see strange lights in the sky that look like auroras. Then, you look at your cell phone, and the current weather data might be gone because the satellite is down. The entire cell phone network may have collapsed. If you use GPS at work, you might have to do without the service. If your work has anything to do with communications, air traffic, or navigation systems, you could find yourself in quite a mess because the old systems simply no longer work. And of course, the pole shift would be the big topic in the newspapers, on the street, and on the subway. Researchers are not yet sure to what extent the Earth's magnetic field influences our internal clock and our own orientation. You might experience mild symptoms of confusion, insomnia, or a certain nervousness after a pole shift. After a few days, the situation would certainly have settled down again once the Earth's magnetic field has reached its new position. If it wobbles for days, weeks, or even years, we humans would have to expect repeated disruptions to our technologies and increased solar storms and UV radiation.